broadest portfolio of high-performance CPU, GPU, and networking products. And when you look at modern data centers today, they actually run many different workloads. They range from traditional IT applications to smaller enterprise LLMs to large-scale AI applications. And you need different compute engines for each of these workloads. And only AMD has the full portfolio of high-performance CPUs and GPUs to address all of these workloads. From our Epyc processors that deliver leadership performance on general-purpose and mixed inferencing AI workloads, to our industry-leading Instinct GPUs that are built for accelerating AI applications at scale. Today, I'm going to share details of our next-generation data center CPU and GPU offerings. So let's start first with CPUs. If you take a look at the CPU market, Epyc is actually the processor of choice for cloud computing, powering internal workloads for all of the largest hyperscalers and more than 900 public instances from all the major cloud providers. Every day, billions of people around the world use cloud services powered by Epyc. That includes Facebook, Instagram, LinkedIn, Microsoft Teams, Zoom, Netflix, WeChat, WhatsApp, and many, many more. All of that is on Epyc. Now, we launched Epyc in 2017, and with every generation, more and more customers have adopted Epyc because of our leading performance, our leading energy efficiency, and our leading total cost of ownership. And I'm very proud to say that we're at 33% share now and growing. Now, when you look at today's data centers, most data centers are actually powered by processors that are more than 5 years old. And when you look at the virtualization performance of our latest generation server CPUs, the new technology is so much better that Epyc delivers 5 times more performance compared to those legacy processors. And even comparing to the best processors today from the competition, our performance is 1.5 times faster. Many enterprises today are actually looking to modernize their general-purpose computing infrastructure and add new AI capabilities, often within the same footprint. And by refreshing their data centers with 4th-gen Epyc, you can really accomplish this. You can actually replace 5 legacy servers with a single server that reduces rack space by 80% and consumes 65% less energy. Now, many enterprise customers are also wanting to run a combination of general-purpose and AI workloads without adding GPUs. And Epyc is, again, the best option for that. Looking at Epyc, we are 1.7 times faster when running the industry-standard TPX AI benchmark that measures end-to-end AI pipeline across different use cases and algorithms. 4th-gen Epyc is clearly the industry's best server CPU, but we're always pushing the envelope to deliver more performance. So I have something to show you today. It's actually the preview of our upcoming 5th-gen Epyc processor, codenamed Turin. So please take a look at Turin for the very first time. Turin features 192 cores and 384 threads and has 13 different chiplets built in 3 and 6 nanometer process technology. There's a lot of technology on Turin. It supports all of the latest memory and I/O standards and is a drop-in replacement for our existing 4th-gen Epyc platforms. Thank you, Drew. Turin will extend Epyc's leadership in general-purpose and high-performance computing workloads. So let's take a look at some of that performance. NAMD is a very compute-intensive scientific software that simulates complex molecular systems and structures. When simulating a 20 million atom model, a 128-core version of Turin is more than 3 times faster than the competition's best, enabling researchers to more quickly complete models that can lead to breakthroughs in drug research, material science, and other fields. Now, Turin also excels at AI inferencing performance when running smaller large language models. So I want to show you a demo here. Now, what this demo compares is the performance of Turin when running a typical enterprise deployment of Llama 2 virtual assistants with a minimum guaranteed latency to ensure a high-quality user experience. Both servers begin by loading multiple Llama 2 instances, with each assistant being asked to summarize an uploaded document. Right away, you can see that the Turin server on the right is adding double the number of sessions in the same amount of time while responding to user requests significantly faster than the competition. And while the other server reaches a maximum number of sessions, you'll see it stop soon, it basically can't support the latency requirements anymore. Turin continues scaling and delivers a sustained throughput of nearly 4 times more tokens per second. And that means when you use Turin, you need less hardware to do the same work. And in addition to leadership summarization performance, Turin also delivers leadership performance across a number of other different enterprise AI use cases, including 2.5 times more performance when translating large documents, and more than 5 times better performance when running a support chatbot. Our customers are super excited about Turin, and I know many of our partners are actually here in the audience today. And I want to say we're on track to launch in the second half of this year. So now let's turn to data center GPUs and some big updates on our Instinct accelerators. We launched MI300 last December, and it's quickly become the fastest ramping product in AMD history. Microsoft, Meta, and Oracle have all adopted MI300. Every major server OEM is offering MI300 platforms. And we have built deep partnerships with a broad ecosystem of CSP and ODM partners. Again, many, many thanks to our ODM partners who are here today that are offering Instinct solutions. Now, if you look at today's enterprise generative AI workloads, MI300X provides out-of-the-box support for all of the most common models, including GPT, Llama, Mistral, Phi, and many more. We've made so much progress in the last year on our ROCm software stack, working very closely with the open source community at every layer of the stack, while adding new features and functionality that make it incredibly easy for customers to deploy AMD Instinct in their software environment. Over the last 6 months, we've added support for more AMD AI hardware and operating systems. We've integrated open source libraries like VLLM and frameworks like JAX. We've enabled support for state-of-the-art attention algorithms. We've improved computation and communication libraries, all of which have contributed to significant increases in the Gen AI performance for MI300. Now, with all of these latest ROCm updates, MI300X delivers significantly better inferencing performance compared to the competition on some of the industry's most demanding and popular models. That is, we are 1.3 times more performance on Meta's latest Llama 3 70B model compared to H100, and we're 1.2 times more performance on Mistral's 7B model. We've also expanded our work with the open source AI community. More than 700,000 Hugging Face models now run out of the box using ROCm on MI300X. This is a direct result of all of our investments in development and test environments that ensure a broad range of models work on Instinct. The industry is also making significant progress at raising the level of abstraction at which developers code to GPUs. We want to do this because people want choice in the industry. And we're really happy to say that we've made significant progress with our partners to enable this. For example, our close collaboration with OpenAI is ensuring full support of MI300X with Triton, providing a vendor-agnostic